Caching is hard. It's one of the 2 to 3 hard problems in computer science, depending on where you're indexing your starting points. It's not easy, it's not fun, but it is important. And we know that not just because I play with it a lot and talk about it a lot, because we had a caching issue with upload thing. Thankfully, it wasn't the type of issue that causes any problems for users. It was just the type of issue that causes problems for our bill. It still didn't get particularly bad, but it could have. And I want to show what could have happened, why it happened, and how we ended up solving it. Because all of these things are kind of unintuitive, and I honestly think it'll be an interesting story. No articles today, just a straightforward explanation of how we were doing caching with upload thing, what went wrong, and how we fixed it. Let's dive into the code. Okay, so the thing that we wanted to have on their site, it's really nice. If you're not already familiar with upload thing, best way to do file uploads for full stack devs. We say just next. It works for everybody. I'll update the site soon, I promise. But if I go to a project like image thing, which is something I use for managing my images, you'll see this little warning here that lets you know that you're on an old version of the upload thing SDK. And it tells you which version you're on, which of your keys are on it, and also to update to the latest version. So how do we do this? We need to know what the latest version is in order to give you this alert. The way we did that was using the NPM API. So what we had in our code base, if I find the code here, we got this data by hitting the NPM registries API, and this would return a bunch of stuff, including the versions that exist for upload thing and a bunch of additional data. And we would cache this in the actual Vercel fetch cache. And by putting these next revalidation tags here, this guarantees that this would be revalidated every 24 hours and no more than that. You pass this a number of seconds, and now this cache can be hit for that much time. So now, whenever we call this particular fetch call with this particular URL and this particular tag, it won't have to go to NPM to get that data, which is important because otherwise NPM would rate limit us. And we want to avoid that. We want to avoid making that call to the best of our ability. And then we just return the response here. We also have a similar fetch that we were doing for getting the minimum supported version so that we could know what the lowest we allowed was. So this is, we would get all of the upload thing API response from NPM. So this is all of the versions that exist for our package. We would cache that response, and then we would get the JSON from it so that we could use that for other things. Specifically, we wanted the versions key from the upload thing versions. So then we have the get minimum version function, and this calls both of the functions we had above there. Specifically, we're calling the list upload thing versions function. This gives us all the versions, and then we go through them, and we find the lowest one that is supported. So if it's canary, we skip it. If it's not, or it's deprecated, then we skip it. But if it's not deprecated, then we now know to assign that to the most recent minimum version that we found so far. So now we have a function that just goes through all of the versions that we got from the API and figures out which one the minimum version is. And then we call both of those functions here, and we use them to do some transforms, and then we send back some data. So why was this a problem? This all seems fine so far. We've made it so we only have to make these fetch calls every 24 hours. All seems good and dandy in the world, right? Things are not as simple as they seem. So what you'll see here is that we were reading a lot of data from our cache. Like, a lot of data. Like the bandwidth that we were getting out of the cache was 4 gigs for the /upload thing registry and up to 2.5 gigs from the upload thing latest. And this was in a 7-day window. That was real bad. And it wasn't enough that we were going to get billed, but it was enough that it could have been a problem. And this happened because we weren't caching what we needed, we were caching what we got. And that's the distinction I want to drive home today. By using the fetch cache, which is what Next uses by default and what is often recommended, we actually were storing way more data than we needed because we were storing everything we got back from these calls. And if I was to go make this call locally and show you what we get, it's a ton of data. See all this shit? We don't need all that shit. We might need it when we're doing the calculation, but ideally we're not going through all of this every single time anyone does anything on our site. This is a lot of data. It's not like gigabytes of data, but it's probably over a megabyte of text. And that pile of data that no one should have to use more than they need to is now being stored in our cache. And every time someone does something, we're pulling all of this data out of the cache. So if thousands of people are requesting a page on our site and each of them has to pull this out of cache in order to generate that page, that sucks. It makes things slower. It increases the amount of bandwidth we're using. It increases the amount of data that we're storing. And generally speaking, makes things harder than they need to be. So how do I solve this? I used a function that most of you guys probably wouldn't have used because of its name. Unstable cache. Unstable cache lets you more granularly pick what caching you're doing. Instead of just blindly caching everything that comes back from fetch, I am now choosing what I specifically want to cache. So you'll notice all the fetch calls no longer have the fetch specific, cache specific things. I got rid of all those next tags that existed in here before that specified what to and not to cache because I don't want these cached. This is way too much data and I don't want to deal with it. So what we're doing now instead is a lot nicer. We have these internal functions that are the functions that call the fetch thing, and I never expose those. Instead, we expose a wrapper, get latest UT version instead of internal, and this just passes internal, but I'm using the unstable cache function. Here you can give it a custom key as well as a revalidate time, just like before. But instead, what this is caching isn't the fetch call that happened in the middle of the function, it's whatever gets returned. So here, all we care about is npm response.version. So the thing that we're caching now as a result is just the version. We're no longer caching this whole response. We're only caching whatever this function responds with. Same deal here, where we have the internal list upload thing versions, and then we have a get minimum upload thing version function, similarly unstable cached. This does a whole bunch of different stuff, but it returns a very small payload. It has the version, and it has a reason. Really simple. And now that we've cached this instead, the thing that we're caching isn't a gigantic HTTP response. What we're caching is just the tiny little bit of the version, min version, and the reason. And we're not caching any of the rest because we don't need to. So how has this affected our bottom line? What should we see now as a result? How do we know it's working? You'll notice that the reads, that the amount of data that we're reading from the cache has gone down a ton. And sadly, this chart doesn't properly let you do like by day. So it's hard to see, oh, here we go. Here's the bandwidth being used by these things. And it has plummeted. The reason for that is we're caching way less data. The amount of writes has gone up because the cache specificity has gone down a tiny bit. But the result is that the responses are holding way less data, are pulling way less data, and it's way faster. If you're seeing undefined and you're confused, undefined means that we're not caching a URL. We're instead using something like unstable cache. This should just say unstable cache, but the Vercel UI has been updated accordingly. So you to see this, you're like, oh, you're only using 5 megs versus this that used almost a gig. You must be doing way less requests. Nope. In this window, 90% of the data cache hits have been going to undefined. Actually, sorry, this is the percentage of requests that were or weren't cached. If we look at the total requests, you'll still see this got significantly more than upload thing latest, but it's using that much less bandwidth. But also, we're hitting the cache 90% of the time. That's great. So we're hitting the cache all the time. We're not storing a ton of data we don't need to store. And our bandwidth that we're using is down orders of magnitude. This is a great win. And generally speaking, you should think about what you actually want to cache. Caching shouldn't just be a thing that magically happens because you made a fetch request like it used to above here. Ideally, caching is a thing you do with intent based on something that you want to save. And you shouldn't want to save everything, which is often what people will do with caching is they'll just throw everything in the cache. That's not a great solution. It's expensive, it's slow, and it largely defeats the purpose of a cache. Since we knew what we wanted, which is we wanted to know the minimum version for upload thing, the latest version, and what version you were using, instead of caching the fetch calls we made to figure out that data, we're now caching the specific responses that we wanted from it. If the fetch call responds with a ton of data that we then do things with, don't cache the response, cache the thing that you did with it after. And as long as you can generate the response again, it doesn't matter if you didn't cache enough because you'll just generate the right response when the time comes. Caching isn't a thing that should be done at every single step along the process. It should be done as close to the result as you possibly can put it. And if we think of this like a pipe, if I hop into my favorite program, Excalidraw, if we have the request that the user made, we'll say that this is a page load. So we want this page to have all the data on it. In this case, we need the minimum upload thing version. In order to make this actually load, we have to do a bunch of things. First, we have to go to the npm API. Then we have to find the lowest response. Then we have to render components. And then finally, we can send this over to the user. Page loaded. So if we have the user doing a page load, so I'll change this to user request. The request goes to the NPM API to figure out what we need. Then we filter that to get the lowest. Then we render the components. Now the page is loaded. The default that we and others reach for is to cache here. Based on the input and the output of the NPM API, we have something saved in our cache. Then we take that cache data, we pump that into our function. We then render the components. Then we load the page. There's a couple different ways we can do this, though. I'm going to move these to make it a bit easier to see, because what I chose to do here is effectively this, where we now cache both the NPM API call and the lowest response. The thing is, we're not caching the individual steps in here. We could separately cache this and this, but that's not what I did. I made a function that does all of these things, and if we go to the code, we could see it. It's the get minimum upload thing version function. So this get minimum upload thing version function has an input and an output, and everything that happens inside it doesn't give a shit about. As long as it knows the input and the output, and when that becomes invalid, we only have to run the compute in here once, which means we only have to fetch from the NPM API once. Before, this was reduced to here, and get minimum upload thing version was a separate function that wasn't cached, so I'll turn that white accordingly, because we would get the fetch call, and then we'd have to process the data. So we'd have way more data, even though this is a smaller box. The amount of data coming out of that, best way to visualize that would be the thickness of these pipes. We have this thick pipe with a ton of data going from there to here, but just with a simple move of caching this more aggressively by putting it there and then moving this arrow because attaching things is hard. Now the amount of data that we're caching goes down, and it is more responsive for the users because we don't have to do that compute every single time. We don't have to load up all that data every single time. You can cache more aggressively though. You could even cache the components being rendered. Next.js makes it very easy to do that. So you actually generate all of the things. And now when the user requests the page, we can effectively shortcut and just give you the response immediately. But you should be thinking about where your cache starts and ends. At what point do you want the input to be measured and linked to a specific response? Because for all I care, if all I want to know is the minimum version right now, I don't care what functions are being called or what data is being fetched. I just want to ask for the minimum version and then get it back. That's a really logical place to put a cache. So think about the logic of where your caching goes, especially because in the future, unstable cache won't be so unstable. There probably won't be the same API either, but there will be something just like this in the future so that we can choose where our data is being cached. And as intuitive as it may feel to cache at the API and fetch level, I find it often isn't. And fetch caching by default might not be the right call. And that's a hot take coming from me because I was the guy who defended the fetch cache for a long time. Speaking of fetching and caching, I'm going to cache my way out of here. Good seeing y'all as always. Peace.